Hey guys, today we're going to be talking about probability, or specifically binomial functions. But before we can get to that, we need to go over a few of the basic concepts of probability, specifically what it is. Now, probability is the odds of a specific event occurring. So for example, let's say you've got this thing here. This is called a D10, or a 10-sided die, because it has 10 sides. With probability, we're trying to ask what are the odds of getting a 4 if I roll this dice. So I can just roll it like that, and I got a 0. In order to get a 4, that is a 10% chance, or 0.1. So each time I roll it, I have a 10% chance of getting what I'm looking for. And that's the very basic principle of probability that leads us into what is next, which is called independence. So you might be asking yourself, just what is independence? Well, it's really quite simple. Let's say I'm going to roll this D10 2 times. The result of the first roll is not going to affect the result of the second roll. For instance, so let's say I roll it, I get a 9. So just because I got a 9 on the first roll does not mean I'm not going to get a 9 on the second one. It's totally independent, which means that for each roll, the result is still 10%. The first one has no impact on the second. And this all leads us to binomial probabilities. Binomials concern themselves with two things: success and failure. Now, what it's asking is, if we go back to the example with our die, what is the odds of getting 3 zeros when I roll the die 5 times? That's what we're calculating, not what is the odds of just getting a 0, but the number of successes out of a certain number of trials. With this die, the chance of success is 10%, just like the last time. The chance of failure is 90%. This is because there's only 1 0 on this die, which means there's 1 in 10 chance, 10%, of being successful. But there are 9 sides where I'm not getting a 0, which makes it a failure, which is 90%, 9 out of 10. In order to be considered binomial, there are 4 qualifications. Number 1, there's a fixed number of trials, which is called n. 2, there's only success or failure. 3, the outcomes of each trial are independent. And 4, the probability of success is the same for each or all trials. So in our example, we have 5 trials. We roll the die 5 times, that's n. Number 2, there's only success or failure. If we're trying to get a 0, there's only 1 0 on that thing, everything else is a failure. Number 3, the outcomes of each trial are independent. Each time we roll the die, something new is going to happen. It's not dependent on the previous roll. And finally, the probability of success is the same for each and all trials. The number of zeros on this die does not change as we keep rolling. It's always 1 out of 10. And so, with our example, we have met the qualifications to be considered binomial. The standard notation for a binomial is this, and it tells you everything that you need to know. One, that's binomial, you can tell by the big B. It'll have the number of trials, n, and the probability of success, which is p. In our example, for instance, with the rolling the die, n is 5, and probability of success is 0.1. So, what if we want to actually find out, not just talk about it, what is the probability of getting 3 zeros out of 5 rolls? Well, you can calculate that by hand. It's pretty simple. All you have to do is take the probability of 3 out of 5, which is equal to the probability that x is equal to 3. Then you have a formula that follows it, which is parentheses nr times 0.1 to the power of success times 0.9 to the power of failure. So the n over r is 5 NCR3 in the calculator. Essentially what that means is it is the number of combinations in which this probability is successful. 0.1 is the probability of success, its number of successes, and 0.9 is the probability of failure to the power of the number of failures. What this ends up being is 10 times 0.1 to the power of 3 times 0.9 to the power of 2, or 0.81%. There is less than 1% chance of, if we roll this die 5 times, getting a 0 on exactly 3 of them. is there are calculator shortcuts that I'm going to talk to you about today. Now, every single one in this video can be found under second distribution on your Texas Instruments calculator, like TI-84, TI-83, that's where you're going to find them. And there's two calc shortcuts with binomials I'm going to be talking to you guys about today, which is Binom PDF and Binom CDF. Now, Binom PDF wants to find out exactly what we calculated by hand. What is the probability when I roll this 5 times of getting exactly 3 successes, 3 zeros? Binom CDF, however, answers 2 different questions. The first one is, what is the probability of getting at most a number of successes? Or, conversely, it can answer the question of, what is the probability of getting at least a certain number of successes? But we'll get into that later. First, let's properly go over Binom PDF. So Binom PDF. When you go into your calculator, second distribution, you'll find Binom PDF. You click on that, and then you can find out the probability of getting 3 successes out of 5 trials. So what this looks like is Binom PDF 5, 0.1, 3. So 5, the first number, is always the number of trials, which is n. 0.1, the second number, as we've gone over, is the probability of success. And the third number, x, or 3, is how many successes exactly are we looking for. Your calculator will calculate this out to 0.81%, just like we calculated by hand. So now let's move on to Binom CDF, which its basic function asks what is the probability that x is less than or equal to 3, or the probability that x is at most 3. When we plug this into our calculator, we find that it's almost the exact same as Binom PDF. The only difference really is it's CDF instead. But the total comes out to 99.95% probability that you'll have at most 3 successes. To flip that on its head a little bit, let's say we want to find out at least 3 successes when I roll the die 5 times, right? Before you can put that in your calculator, you have to do a little bit of math. You have to find 1 minus the probability that x is at most 2, because Binom CDF only ever solves for at most. So we need to find 1 minus its opposite, which is at most 2 instead of at least 3. We plug this into our calculator, we find that we have 2 replacing 3 where the x would normally go. And that totals out to 0.856%, which is less than 1% chance of getting at least 3 successes when you roll this die 5 times. Hey guys, thanks so much for watching this video on probability. Today we went over what probability is, what independence is, and then binomial functions with using this D10 as an example. Once again, thank you so much for watching this video today, and I hope you just learned a little bit more about probability, so the next time you need to know what the chances of success and failure are, well, you can figure it out yourself.